Touchdown confirmed. Perseverance safely on the surface of Mars.
NASA successfully landed its Perseverance rover on Mars.
The only way to answer it, NASA believes, is to do what they're doing now. Go to another planet, assess it thoroughly.
A snapshot from Mars has rocked the scientific world, changing the way we think about the red planet.
So we'll know exactly how old this part of Mars is.
The remarkable Belva Crater, a 0.6-mile impact crater on Mars, bears a striking resemblance to Earth's deserts, such as the Sahara or the Kalahari. Situated within the expansive Jezero Crater, spanning 28 miles, Belva is believed to have once been submerged in water. This captivating landscape, along with 5-foot boulders and earth-toned soil, was immortalized in stunning 4K footage by NASA's Mars Rover, Perseverance. What exactly lies within the confines of the Belva Crater? How did the Perseverance rover manage to capture such breathtaking footage? Join us as we unravel the incredible image of Belva Crater recently transmitted by the advanced technology of Perseverance. Perseverance captured stunning 4K photos of Belva Crater. On top of the western delta of Jezero Crater lies the Belva Crater, a 0.6-mile broad crater. A delta which is made up of sediment layers, relationships, structures, and other attributes can reveal a wealth of interesting information about the type of water body that gave rise to it. Mastcam-Z captured some excellent photos of the interior and surrounds of Belva Crater to aid scientists in learning more about the geological and stratigraphic history of the Jezero Crater. There are craters all across the planet Mars. Almost any orbital scale's worth of pictures shows that the majority of Mars's surface is made up of rounded depressions of varying sizes. Certain craters swallow entire regions. Viking 2 landed in 1976 on Utopia Crater, which is 2,100 miles wide. In contrast, some are quite small. For example, the Opportunity rover discovered 3.9 to 7.9-inch miniature craters in Meridiani Planum in 2005. In this sense, Mars is not special. There are impact craters of all sizes on Mercury, the Moon, and many other bodies in our solar system. You need to understand the past and present circumstances of Mars to understand why the planet is so rich in craters. Mars lacks the kind of extensive geologic activity that would conceal its numerous old scars. It is a dry, arid planet. We think that this is how things have always been for a very long time. The planet Earth is and has nearly always been extremely active. Plate tectonics, volcanic eruptions, landslides, glaciers, large bodies of water, and biological activity, including the widespread landscape redecorating that people have done over time, are among the natural phenomena that we encounter. Impact craters can be buried, eroded, and eliminated by any of these processes. Many of Mars's craters have survived because the planet has been significantly less active over most of its history. In fact, this is highly advantageous for carrying out scientific research on Mars. Craters are crucial to our exploration of Mars. Essential geologic features that are a reminder of previous water can be found in craters. On prehistoric Mars, water was able to flow to and settle in topographic lows. It is possible that numerous craters on Mars were formerly lakes that were supplied with water by rivers. That planet is very different from the familiar dry and dusty Mars. Some of the finest locations to look for evidence of Mars's wet history are its craters, as many of them may have formerly supported substantial and long-lasting volumes of water. One such crater lake habitat is thought to have existed in the Jezero Crater, with its 2 entrance channels, exquisitely preserved river deltas, and outlet channel. Thanks to these craters explored in previous probe missions, we know that liquid water once existed on Mars, and where there is liquid water, there is a chance for life. Although this was a fantastic finding when it was made in the 1970s, it does not provide evidence of life on Mars. Scientists are hoping that they will be able to find the answers we need in Belva Crater and its larger counterpart, Jezero Crater. Tolling pictures in the red planet, as you may have guessed, is not as easy as simply taking a selfie at the park. Let's explore how the footage from Belva came about. The incredible sights and sounds from Belva. The gathered photos from Belva Crater have been pieced together into a striking mosaic that not only looks amazing, but also gives the rover's science team some profound new understanding of Jezero's interior. This imagery featured a magnificent mosaic of 152 images taken on Sol 772. Impact craters can offer expansive views and vertical cuts that offer crucial hints about the origin of the rocks they contain at a scale and perspective that is normally beyond our experience, which is why Belva is so significant to this finding. Scientists are very careful about how they image craters like Belva because of the valuable information they offer to our understanding of area geology. The Mastcam-Z team does more than just point and click at random. Planning for this kind of image is meticulous and thorough. So intricate that researchers use an array of instruments to guarantee they obtain the most scientifically valuable output for the Perseverance team. Andreas Bechtold is a member of the Mastcam-Z science team and a PhD candidate at the University of Vienna. He explains how another Belva Crater mosaic taken on Sol 792, May 13, 2023, was planned using an advanced 3D photography tool. The interactive viewer for 3D visualizations and analysis utilized in the Belva Crater imaging process is called Pro-3D or Planetary Robotics 3D. With the use of this software, 3D data extracted from stereo camera photos of the Mars rover can be used to quantify various geological properties, such as heights, distances, and geometric relationships. Pro-3D can be used as a view planner for Mastcam-Z and other Mars rover cameras, when combined with a digital terrain model, DTM, from the HiRISE instrument on board the Mars Reconnaissance Orbiter. To support the Mastcam-Z imaging of the Belva Crater, a DTM of the western portion of the Jezero Crater was utilized for planning. The level of detail in the entire process is made clear to us by the use of 3 overview photos, A, B, and C. The authentic 110mm Mastcam-Z mosaic of the Belva Crater is displayed in A. It was captured at a spot close to Echo Creek on the western fan top of the Jezero Crater. The image's grid lines indicate elevation and azimuth. Azimuth is measured in degrees, with 0 degrees representing due north and 180 degrees representing due south in the so-called site frame coordinate system. Elevation normally varies from -70 degrees at the lowest position to +10 degrees at the highest point, giving our mosaic's vertical pointing some perspective. On the HiRISE DTM of the Jezero Crater with Pro-3D, a virtual Mastcam-Z camera has been placed at a different site close to Echo Creek for B. The mosaic in B was made by stitching together 9 replicated Mastcam-Z 110mm photos that were taken using Pro-3D's instrument view tool. 32 virtual Mastcam-Z photos have been used to mimic the mosaic in C in the same manner. The 2 simulated mosaics help determine the ideal rover position for the imaging of the Belva Crater, with the outcome displayed in A. They also demonstrated how a genuine Mastcam-Z mosaic from these particular sites would appear. But what exactly is Perseverance, and how do its capabilities help us in our quest to understand if there was ever life on the Red Planet? Perseverance Rover is as small as a car. Built to investigate the Jezero Crater on Mars as part of NASA's Mars 2020 project, Perseverance, also known as Percy, is a car-sized Mars rover. In mid-2020, it was launched from the Jet Propulsion Laboratory. On February 18, 2021, confirmation that the rover had touched down on Mars was received. As of March 11, 2024, Perseverance has been operating on Mars for 1,087 sols, or 1,117 Earth days, or 3 years and 22 days. NASA dubbed the landing location Octavia E. Butler Landing after the rover arrived. The Curiosity rover, which was its predecessor, served as the model for the Perseverance. The body layout, landing mechanism, cruise stage, and power system of the 2 rovers are identical, although Perseverance's design was enhanced in several ways. Perseverance's wheels are more robust and thicker than Curiosity's. The rover's wheels were also made to be stronger than Curiosity's, which had taken considerable damage. Compared to Curiosity's 20-inch wheels, Perseverance's aluminum wheels are thicker, more durable, have a smaller width, and have a larger diameter of 20.7 inches. The aluminum wheels have curved titanium spokes for springy support and cleats for traction. Phenolic impregnated carbon ablator, PICA, was used to make the rover's heat shield. The use of PICA allowed it to endure temperatures as high as 2,400 degrees Fahrenheit. The rover has a robotic arm similar to Curiosity's, although Perseverance's is longer and more powerful at 6 feet and 11 inches. To preserve geologic samples from the Martian surface in sterile caching tubes, the arm is equipped with a sophisticated rock coring and sampling system. Additionally, the rover has a second arm that is concealed beneath it that aids in storing the chalk-sized samples. Located on the underside of the rover, the Sample Handling Assembly (SHA) arm is in charge of transporting soil samples to different locations inside the Adaptive Caching Assembly (ACA). Among the stations on Perseverance are the Hermetic Seal Station, Imaging, Seal Dispensing, and Volume Evaluation, which measures the length of the sample. The sample caching system is the most intricate and advanced mechanism we have ever tested and prepared for spaceflight because of the limited area in which the SHA must function and the load requirements during sealing operations. The multi-mission radioisotope thermoelectric generator, MMRTG, on the rover weighs 99 pounds and is powered by 11 pounds of plutonium-238 oxide. With a half-life of 87.7 years, plutonium-238 naturally decays to produce heat that is turned into energy, 110 watts at launch. As its power supply deteriorates over time, this will get smaller. The rover's operations are powered by 2 lithium-ion rechargeable batteries that are charged by the MMRTG and require regular recharging. Engineers have much more freedom with the MMRTG to operate the rover's sensors even at night during dust storms and during the winter than they would with solar panels. The computer utilized by the rover is a radiation-hardened single-board computer. The BAE Systems RAD750, which is built around a ruggedized PowerPC G3 CPU, PowerPC 750, the computer operates at 133 MHz and has 128 megabytes of volatile DRAM. The flight software is developed in C using the VxWorks operating system and has access to 4 gigabytes of NAND non-volatile memory on a different card. Perseverance's telemetry depends on 3 antennas, all of which are transmitted by spacecraft that are presently circling Mars. A maximum of 2 megabits per second of data can be transmitted from the rover via the primary UHF antenna. Redundancy in communications is provided by 2 slower X-band antennas. The SuperCam is a powerful camera mounted on the mast of Perseverance that uses a laser to determine the composition of rugs. This instrument is extremely important because it can analyze a rock from a distance of several meters, meaning the rover doesn't have to move within arm's reach of the rock it wants to identify, allowing it to move on to a new region more quickly. Additionally, 3 3D panorama cameras are mounted on the mast. These cameras can focus, zoom, and record video once interesting rocks have been identified using the cameras. Perseverance can come closer and use the spectrometers in its arm to examine them. The arm has 2 cameras, a normal color camera called Watson and a second laser camera called Sherlock that can also take microscopic images. These images were found in the raw files of the cameras, and they were brought along to test the camera's focus and the laser's ability to read the material correctly. The rover is equipped with a variety of materials, including spacesuit fabric and some with Easter eggs related to Sherlock Holmes, such as the maze with a small image of the detective in the middle and a rock sample with the renowned address 221 B. Baker from the book. At the back of the rover, there is a ground-penetrating radar instrument that will be used to see the geologic features beneath the surface. There is also a rather special experiment module called MOXIE that will be used to see if oxygen can be extracted from the Martian atmosphere, which is crucial for the survival of future human colonies, and surprisingly, even a way to produce rocket fuel. One of these rock cross-sections is reportedly actually from a suspected Mars meteorite. If true, this would be the first known instance of a rock from Mars making a full trip home. The last experiment on board relates to Perseverance's main goal of finding compelling rocks that may host microbial fossils. Because leaving a planet's gravity naturally requires a lot of fuel, even though Mars has a lighter gravity, it still requires 30 to 40 metric tons of propellant. This makes the task more difficult on Earth, and even more difficult if you have to carry all the fuel you will need to make the trip home. Moreover, some witness tubes are preloaded with witness materials that can capture molecular and particulate contaminants. Each witness tube will be opened on Mars to capture the ambient environment before being sealed like regular sample tubes. The samples were cleaned as much as possible before launch to avoid contaminating Mars. Even tiny traces of gases from the rover itself could skew readings. By comparing the cache samples with the witness tubes, scientists will be able to identify and remove any impurities. Sadly, because Perseverance is meant to be a forerunner mission, rather than a mission to confirm the existence of microbial life on its own, once it has filled all the caches, it will store them for a later mission to retrieve. NASA wants this to be a sample return mission, but the method of retrieving these samples has not been finalized yet. The launch is scheduled for 2026, and it will involve a rover retrieving the samples and returning them to a rocket, which will then rendezvous with an orbiter to return home with the samples in hand by 2028. Given the complexity of the system, we can only hope that the mission teams in the upcoming years will truly do everything right. Once promising candidates have been identified by the camera and spectrometer, the arm is equipped with a drill that can either remove a rock's top layer to reveal the unweathered surface underneath, or if the mission team wants to remove a sample from the rock, the drill can remove a chunk. The arm will feed the sample through to the rover's body, where a second arm will move the core to a sealed area before storing it in one of the 20 caches that will be on board. But the Perseverance's build is not the only thing about it that speaks to its manufacturing prowess. The questionable landing on the moon. On July 30th, 2020, Perseverance was launched aboard an Atlas V rocket. Around this period, there was a fantastic launch window where Mars and Earth were perfectly aligned for a brief encounter. Perseverance's system was inspected during the 7-month journey, and results indicated that it was ready for atmospheric entry. The most terrifying aspect of the entire trip was landing. It was extremely risky because of the temperature and speed extremes involved. However, NASA had a lot of experience with it and appeared to be improving with each attempt. It takes some skill to land a car-sized rover on a different planet. First, the cruise stage is disconnected and thrusters are employed to stop the craft from spinning at a speed of almost 16,000 kilometers per hour, roughly 4,000 kilometers from the landing spot. The craft reaches a speed of over 19,000 kilometers per hour at a height of 120 kilometers. However, this is also the point at which Perseverance's speed is reduced by the Martian atmosphere. Thrusters are employed to maintain spacecraft stability and to keep the heat shield facing forward as a result of atmospheric turbulence, which is heating the shield to temperatures above 2,372 degrees Fahrenheit. Its position is automatically tracked by onboard computers, which keep it pointed toward its ultimate landing objective, which is 16 kilometers away and 60 kilometers above. Perseverance's velocity is reduced to 3,000 kilometers per hour by the atmosphere. The spacecraft is equipped with multiple video cameras, providing us with an unparalleled view of the landing phase. This is where things start to get interesting. The massive 21-meter parachute was opened first. Scientists can use the parachute's peculiar red and white pattern to determine its orientation. But there's also a secret code inside that has the NASA Jet Propulsion Laboratory motto in binary, along with JPL's GPS location. The heat shield is released, lowering the weight and allowing Perseverance to come into contact with the Martian atmosphere for the first time, at a height of 10 kilometers and a speed of 600 kilometers per hour. The spaceship starts imaging the Earth at about 4 kilometers altitude to find a safe landing spot 2 kilometers above. When it finds a good landing location, the spacecraft's upper shell splits, leaving only persistence and the rocket-propelled descent stage, which are essential because the parachute is no longer able to slow the fall. The rocket cannot survive in the thin atmosphere of Mars. The stage hovers 20 meters over the ground, slowing the descent from 300 kilometers per hour to 0. After the rover is securely on the ground, the rocket stage cuts loose and crashes a safe distance away. The rover is then lowered using a cable that is suspended by an apparatus called the sky crane. It is amazing that on February 18, 2021, Perseverance, after a 7-month journey, touched down on the planet Mars. Scientists had brought Perseverance to a place where its wheels could transport it freely and where it could find sites of particular scientific interest. As the rover turned on its cameras and took in its surroundings for the first time, it found itself staring out across the red, arid, and solitary landscape that we have come to expect from Mars. The terrain surrounding it, the Jezero Crater, was mostly flat, though scattered with rocky outcrops. To help scientists piece together the geological history of the Jezero Crater and to get a better idea of the most likely locations to find life persistence, in locating rock outcroppings around the crater has made it possible to gather rock samples from a variety of geological periods without the need for extensive drilling. Before moving on to the Jezero Delta as part of the Delta Front campaign, scientists would first spend some time examining the areas of the crater near its landing site. The technological marvel that is Perseverance has one more trick up its sleeve, and it would amaze everyone outside of the scientist community that built it. Perseverance gave birth to a brand new technology. Despite landing on Mars in February, you would think that Perseverance would be eager to start its mission almost immediately because of the rock outcroppings surrounding the crater, which would allow it to gather rock samples from many different geological periods and give it plenty of opportunity to get started. However, you would be mistaken. Perseverance didn't make any significant effort to leave its landing site and start its journey until almost 5 months later. And this wasn't just because scientists took their time meticulously testing every piece of scientific equipment and its software to ensure everything was operating as intended. Perseverance wasn't alone. You might be surprised to learn that it was because Perseverance was expecting a child. Nestled within Perseverance's undercarriage, shielded from the Martian winds and atmosphere by a dust shield, was a second, smaller guest that Perseverance had carried to Mars. A significant portion of Perseverance's first few months on the planet was devoted to assisting in the birth of this second passenger. This second traveler was to be both an intriguing tech demonstration and Perseverance's traveling buddy. This little robot, called Ingenuity, was the first such attempt at a helicopter on Mars. It was not a rover. Scientists tested Perseverance's hardware and software for a while before focusing on this smaller 3.96-pound drone. Because Mars's atmosphere is so much thinner than Earth's, it is not clear whether a helicopter's spinning blades would even function there, because it would be difficult to displace enough air to create lift. Its rotor could spin at speeds of almost 2,000 RPM because Ingenuity was incredibly light in comparison. Its only scientific instrument was a camera, but this would be crucial in assisting Perseverance in figuring out the best pathways across the possibly treacherous Martian terrain. Thus, on March 21st, about a month after arrival, Perseverance started the childbirth process by taking off its dash shield, letting Ingenuity experience the taste of Martian air. Mechanical birthing is a laborious procedure, but because scientists are always double-checking every piece of information to make sure everything is working as it should, Perseverance took until April 3rd to finally set Ingenuity down on the hard Martian soil and enable it to endure its first frigid night on the planet. During this phase of Perseverance's mission, it looked on like a proud parent as Ingenuity began to take its first wobbling steps. However, just like a parent, Perseverance couldn't resist taking a few selfies to show off to its friends on Earth. Temperatures on Mars can drop to minus 212 degrees Fahrenheit, so it's no small thing that Ingenuity survived the night without any issues outside of the protective heaters of Perseverance. When Ingenuity took its time testing its rotors at different speeds, its initial flights did not go entirely as planned. The experts working on it were concerned about some software problems that Ingenuity encountered, but on April 19, Perseverance managed to capture footage of the solar-powered drone attempting the first-ever controlled flight on a different planet. Because there were many unknowns and the time it would take for a signal to get from Earth to Mars would cause too much lag, the flight was completed autonomously. It is difficult to accurately replicate lower gravity on Earth, for example, so testing the rotor here didn't guarantee it would work there. Fortunately, and with incredible smoothness, Ingenuity rose to a height of 3 meters and hovered there for 39.1 seconds, exactly as planned. Mars has a lighter gravity than Earth in addition to having thinner air. When the tech demo, which had been presented just 6 years prior, proved to be successful, scientists were ecstatic. It was not anticipated that Ingenuity would survive on Mars for very long, but it did. It continued to fly higher and farther than any previous attempt, didn't break or crash, and has even grown to be a helpful scout for Perseverance, helping it find good routes for the rover to travel or look for points of interest that are too small for satellites to detect. From being a temporary technological demonstration at the start of the mission, ingenuity evolved into a vital ally and partner for the Perseverance rover. The Martian rover Perseverance was able to try out a lot of its equipment while it waited for Ingenuity, so it wasn't entirely inactive during this period. Soon after landing on Mars, Perseverance, which had a microphone attached to it, listened in the hopes of obtaining the first audio sample from the Martian surface. Perseverance was able to accomplish this, providing us with the first impression of the sound of the wind on Mars, which undoubtedly contributes to the bleak atmosphere of the terrain. It was time for Perseverance to begin to answer the question it was put on Mars to answer. Is there life on Mars? Perseverance adapts to life on Mars. Perseverance also spent time traveling modest distances to test its systems. In addition to taking pictures of the surrounding area, the rover used its MOXIE instrument to successfully extract oxygen from carbon dioxide in the atmosphere of the red planet. This process produced about 10 grams of oxygen in an hour, which may not seem like much, but to be fair, MOXIE is only a prototype that is roughly the size of a car battery. If it were to be used on the red planet for human purposes, it would need to be 100 times larger. Even though it's exciting that it functions, there is still one crucial task Perseverance needed to complete. It had traveled to Mars to find out whether life had ever existed there. So during this time of inactivity, scientists were busy figuring out the best course of action for Perseverance. Perseverance's landing was one of NASA's most precise landings on Mars to date, but it still took several days to reach some of the 40-meter-tall rock outcroppings near the crater's edge, which is known as South Side. Between the South Side and Perseverance landing site, there is a hazardous dunes area with loose sand that is impossible for the rover to pass without running the risk of becoming trapped forever, which would mean the mission's end. This is where the scientists are waiting to examine. It would be up to scientists to choose the best path around the dunes. It ultimately came down to efficiency, as is often the case in space exploration, whether it was better to travel counterclockwise around the crater, which would get Perseverance to the outcroppings faster, or clockwise, which would take longer, but allow the rover to stop by more interesting rocks along the way. To give the rover as much time as possible to do as much research as possible in as many areas as possible, scientists opted for the second option. Finally, Perseverance received the all-clear, and on June 1st of that year, nearly 5 months after landing on the red planet, Perseverance's wheels turned over, and the rover departed the security of its landing site to begin its main mission, gathering core rock samples from areas where life may have once flourished in preparation for their eventual return to Earth for analysis. Mission scientists continue to study and discuss the geology at Belva Crater, but we have observed some interesting things. According to an official mission report, strata of steeply sloping bedrock have provided clues regarding Jezero's wet pass. These findings could be the remains of an ancient sandbar. The fact that Mars is so severely cratered is fortunate for our continued exploration. To have a more comprehensive understanding of the geologic history of Mars, we require a look below the surface. Craters are frequently excellent at supplying that. When we find a crater with intriguing geology, Mastcam-Z goes above and beyond to produce amazing photos. Enjoyed that account of Perseverance's exploration of the Belva Crater? Please give this video a like and subscribe to our channel for more entertaining videos like this one. Thanks for watching.